that is a bit tricky. You know why? Because if you bought it and it's not by topic, what happened is you can still use it, but it's tedious. What do I mean by tedious? It means to say that maybe you must, yes, maybe you must go to like 2015 year paper and go and see which question is under the topic of kinematics. Yeah. Then you must go 2016 and go and find kinematics question. 2017 paper, go and find kinematics question. 2018, and plus you're a student, right? You may not know exactly which question is what, right? So my suggestion is buy the topical one because it will definitely use up for 1 whole year. Then it's also a good practice because if you actually buy the topical one, it's very clear cut. Like for example, WA is on chapter 1 and 2. Then you can do chapter 1 and chapter 2. Very quick and easy. Then even when you're in Sec 4, you study those topical like radio activity or whatever, you can also practice. Then by the time you reach the year paper, the yearly test which we will encourage you to buy next year, it's going to be the same question, but you will bound to have it wrong again. Means you sure make a mistake because who actually can remember all the questions you did in your whole entire lifetime? Not possible one. So that's where we practice again. But the new year paper, right? Of course, the yearly paper you can choose not to buy it. Because they, oh, I do before already. The most I redo my topical, which is also possible. But the thing is you know you do math. If a teacher gives you chapter 2, maybe 10 questions you do it. As you do, you become more and more. You are so good at it because you're doing the same kind of question. So when it comes to yearly paper, right, we do not want to have that kind of custom to like, oh, able to do all the kinematics questions. That kind of thing we don't want to. Why? Because we want your brain to be able to twist from topic to topic. Like for example, chapter 2 is kinematics, chapter 3 is pressure and forces and stuff like that. So your brain must switch to, oh, for a moment I thought about speed time, acceleration. Next moment I thought about pressure, force over area. Then after that I must switch to, you get me? Energy and things like this. So it's a different kind of thing. It doesn't mean that you do very well in topical, you can do very well in yearly. It doesn't mean that way because the brain need to switch accordingly. It's like for example, if I'm a Caucasian and beside me is a lady from China, you need to speak to me in English and you need to speak to her in Mandarin. You also will take some time to switch your brain a bit, like to talk in Chinese and to speak in English. So usually we encourage our students to buy 2 different books. Usually, but of course you can say no. No one's going to force you. Okay, so by the way, WA is set by Mr. Quack already. It's for topic 1 and 2. So kinematics is 1, which is chapter 2. Then the other one, it was the measurement and taught by Mr. Liao and myself. Okay, so chapter 1 and 2 only on the 18th of February. So basically you will sit in during class time. Okay, again, like I said, WA, we try not to absent ourselves. Okay, because it's a good practice. But of course, if you are sick, right, do remember to take an MC. Because if you write parents' letter, you will get a 0 for this paper. Okay, you all know this already. Okay, any question? No, okay, just a quick reminder, Google Classroom. Okay, all in. Got so many people. 2, 4, 6, 7. Okay, correct. I give you classwork, right? Okay. How many people haven't handed in yet? 3. Okay. So I'm going to mark it later. So these 3 of you, if you can, do it by tonight, can? So that at least before WA starts, we can clear chapter 1 and 2 from 10 series. At least this is what we can prep you with. Got it, girls? Okay, now let's go to the notes. By the way, the 10 series that I gave to you for kinematics, if possible, let me see when's the next lesson, okay? When's the next lesson? Is it tomorrow? Oh, it's tomorrow. 18. Wow. You think you can finish by tomorrow? Tough, right? Is it tough? If today no homework, then of course it's not tough. Or at least finish MCQ. Okay? Doable? Right? So because tomorrow is our lesson, sadly, okay? Because it's one after another, I'm sure I don't like it. Okay, so try to finish at least the MCQ. Alright? And if you can manage to attempt the structured question, by all means attempt it. I will most probably do one question with you, okay, just to show you how do I do it. Then the rest you leave it as homework. Then on the 10th, right, you will come back in, then we will do the correction together. All clear? So basically for homework for today, okay, let's write down. Homework for today is the 3rd of February. What happened is the TYS topical on the topic of chapter 2, topical TYS MCQ. Okay, that's your homework for today. So tomorrow, hand in. Deadline. Tomorrow is the 4th. 2025. Okay. Done. Okay, but of course you can do more. Okay, no one is stopping you. Okay, now we do the correction. Okay, over here. This was a homework over the long holidays. Okay, ready? So after doing this, most likely you should be able to do the test series already. Okay, it should be quite similar. And let me tell you, there is a lot of questions tested for kinematics than the first chapter. Because first chapter, you know, like, it's very general. It's like just units and instrument, okay? Majority of the question comes from here. And in a typical O-level setting, right, definitely this chapter is tested one. And it has to be a long question. See, like this, okay? So now, let's do this together. Ready? Can okay. Anyone didn't do? Okay. I'm just telling you, you do or don't do, up to you, okay? Of course, this sounds very bad as a teacher, right? I shouldn't say this kind of nonsense, right? But the thing is, it's really up to you, because if you don't do it, I cannot force your hands to move, right? Okay, at the end of the day, you must be willing. It's like your parents sometimes send you for tuition, but you are very unwilling to go for tuition. Then when you go there, do you learn something? You won't learn much. Maybe you learn a little bit, but you don't learn as much because you yourself are not convinced that you need tuitions. Right? But if you are the one who actually requested for tuition and you go for the class, high chance you're going to learn a lot of things and you will definitely have a great job. Definitely. Okay? So it's all about the willing hearts. If you don't feel like you want to do this, no one can force you. At the end of the day, of course, you can still copy my answer. You can listen to my recording and copy my answer. At the end of the day, whether or not it goes to your brain, I cannot guarantee anymore. Because if you do it by yourself, you think. So when you think, you actually crack your brain and think of the answer and working, it will be more impressionable based on human brain studying. Okay, it's going to be like that one. If you don't put in effort, like for example, today I ate something for lunch. You ask me tomorrow what do I have for lunch today, I will not remember because I don't need to put in a lot of effort to think. But if I'm the one cooking it, then most likely I will remember what I ate today. Because you have to crack your brain what to cook, put in the ingredients, control the fire, you put in a lot of effort. You will definitely remember one. Okay? Hopefully this one can inspire you to do more work next time. Okay, so over here, first thing first, in any kinematics question, the first thing that they give to you, if it's a graph, you must always ask yourself, what graph is this? Then after that, then you can write down all this. So my y-axis is speed. Of course, you don't have to write this. I'm just teaching your brain how it should work. Okay, I'm just training your brain how you should think. Okay, so y-axis, x-axis give you these two quantity. On top of it, gradient. It gives you acceleration. Area under graph gives you distance. Okay? So these are the things that you have to know. So when they give you a question like this, acceleration between A and B. So A and B is where? A and B is here. I love to use color coding for my notes, so at least you can match it. So question 1A, I'll use blue, then 1B, maybe I'll use green. It's easier to see in different parts of the graphs. Okay? Ready? When all of you are ready, then I will go through because I scared you cannot hear what I say. Okay, good. So acceleration, use the formula A equals to V minus U over T. V being final velocity, U being initial. Then T is total time. So this will give you final is 10, okay? 10 minus starting is 0 lah, is default, okay? Then total time taken is 5. So it would be 2 meter per second squared. Okay? Sorry, you should write 2.0. Why 2.0? Because you can see over here, most of the numbers are in 2 sig fig. Okay? This one you will slowly take time to understand, okay? Don't have to rush yourself to doing this. If you write 2 meter per second, you will still get it correct for the time being. Okay? Any question regarding this? Quite simple, right? Because you know what is going on. Next question. It says that you are supposed to find the acceleration of the car between B and C. B and C. Mr. Quack is very smart. He say what? Okay? If the question wants to help you, this question over here would be rephrased by the word state. I'm teaching you examination technique right now. Don't fall asleep. It's a very precious lesson with me, okay? Really, really. I don't just teach you the topic, I teach you questioning technique as well. So whenever you see the word state, meaning you don't have to do any working, the answer should be able to derive just by looking at the picture or at the keywords. Okay? So there's no working needed. Alright? But of course he say what, then it's very ambiguous lah. Then you think, hey, whether should I do working or not do working? Of course it's not wrong to do working. Okay, it's not wrong, okay? I'm going to show you 2 different methods. Method number 1 is with working. Okay, working. So if you blur, you don't know what is going on, then you want to do working, of course you can. So what do I do? Final, right? Final usually is taken from C. C is your final mark. Right, so it's 10. Then initial because B to C, right? So B will be my initial, right? Also 10. Total time taken is from here to here, right? So it will be 5. So I will get 0. This is where you do working. If you don't need to do working, what happens? Because the gradient is 0, therefore acceleration would be 0 meter per second square. Simple. Right? It's a horizontal gradient. Horizontal gradient is always 0. Okay? Because it's horizontal. So must remember in exam O levels, if you see the word state and the blank they give you like very little space only, it's very high chance that you don't have to do working one. Yeah.
In the graph it said from B to C, like there's no like increase, right? So I just put 0 like without the formula.
Yeah. That means all this actually don't need one. They give you 1 mark, which is the blank 1 mark. That means you put your answer in the blank, you should make it 1 mark. So the way you transfer your answer is very important. You transfer wrongly, that 1 mark belongs to the blank. You transfer wrongly, 0. Okay? Next, deceleration. So if you look at the graph, deceleration between C to D, it is from here. So same thing again. Because they say deceleration, doesn't matter. I keep it at the back of my mind. I just use A equals to V minus U over T. Okay, I'm preparing myself to get a negative answer. Okay, because deceleration, right? I got no space, that's why I'm equal like this. Okay, by right shouldn't. So 0 minus 10. Divide by total time from 10 to 20, it should be 10 as well. So you realize my answer is a negative 1 meter per second square. But this is acceleration. You see that? This is acceleration. Okay, that's why it's negative. Okay, but now I have to change to deceleration. I have to write a liner over there, okay? During exam, if a space is given to you, you don't have to write this additional thing over here. Because the blank would have said deceleration. So even though your working shows a negative 1, the way you transfer your answer should be just 1 meter per second square. You understand what I'm talking about? The reason why I'm rewriting the word deceleration equals to 1 meter per second square is because Then you transfer this answer here. Remember to remove the sign. Can already. Everybody understand what I'm talking about? Okay. Next, total displacement. I know this word is very scary because it's a vector quantity. Okay, let me tell you, it's not scary. Okay, so how do I find total displacement? I basically find the area under graph. Whole thing. Okay. Okay. What should I do to ensure that my vector quantity will not have any mistake? You literally just copy all the values that you see on the y-axis and x-axis and you use them as numbers, you won't make a mistake. The whole idea over here, if, let's say you are not good with your mathematics, you don't understand what shape is this. What shape is this, girls? Trapezium. Okay? Trapezium. If you do not know that this is a trapezium, it's okay. I have students who actually do this. Right? So they actually calculate the area of shape 1, calculate the area of shape 2, calculate the area of shape 3, and they add up together. The whole idea here is add and add. Okay? Okay? So how do you do this? Let's say, for example, you really do not know the formula of trapezium. You decide to do it like that. You will use what? This is half times base, which is 5 times 10. This ink over here will not be there for long because I'm holding on to it, okay? So later on, it will go missing one, okay? Because I don't want to make my diagram very ugly, okay? So I must plus what? Plus 5, which is the breadth, times height, which is 10. Plus half times breadth is 10 times height is also 10. How do I get all these numbers over here? I'm basically copying all the numbers I see over here. All the different numbers. Okay? I didn't use my imagination or whatsoever. So if you actually do this, even if it's a displacement question, just like this question, you will not make a mistake. Okay? Understand? But if you know, okay, let's say why I'm saying this, you may think that, Miss Pang, you saying the obvious, right? Of course, I copy the numbers at the side, like who actually imagine numbers, right? Because sometimes the graph may look like this. You see the extension? It went to the negative region. And because it went to the negative region, what happens? Over here, maybe I got -5, -10. So if I were to find out the displacement over here, what will happen? I would naturally have a negative number. How come? So it becomes, for example, this is until 30. So it will be half times -10. Why -10? Because this number here is a -10. Times height, which is, breadth. This is your height, times breadth. Breadth will be 10. See? So I have to just follow whatever the axis mentioned. That will actually give me the value. So that means the value over here, what will happen? It will become a negative. You understand? Then I just plus everything together. So it will automatically minus by itself. You understand me? Okay or not, girls? So that's the reason why they use the word displacement, because they don't want it to be so obvious. So in this case here, because it's a trapezium, area of trapezium is what? Area of trapezium is half times sum of parallel sides times height. You don't have to write this down during exam, okay? Or test. You don't have to. No one cares actually. Okay? So I'm just guiding you through because some of you do not know that it's a trapezium. So half sum of parallel sides means what? Okay, let me show you. This is your parallel sides. This one and this one. These two are your parallel sides. Alright, these two are parallel sides. So it is actually 5 and 1, 2, 3, 4, 20. Okay, 20. So it will be 5 plus 20. Okay? Then times height. Height will be how high this fella is. So it's 10. So it will be 5 times 25, 5, 10, 125 meters. Like that. Next question, average speed, 20 seconds, mainly telling you that the whole chunk over here, this whole chunk is 20 seconds, right? So, total distance over total time, okay? Do you think my displacement over here, this is my displacement, right? Can it be my distance? Can it be my distance? What do you think? This is displacement, right, guys? Ayo, spell wrongly. Wait, let me write clearly. Use a red color. Displacement. Can this also be my distance? Can this be distance? Yes. Okay, why? Because I don't have the negative region. Okay? So displacement and distance over here, they are basically the same. Because no negative region for the graph. That means the graph didn't go deep down. You get me? It didn't went down this way. It didn't go down this way. This part is not there. This is the negative region. Okay? It didn't have. So basically this car is actually going in one direction, like one direction. So when it's going in one direction, so this one it shows that it's one direction. Okay, going in one direction. Because it's going in one direction, therefore displacement and distance is the same. So I could actually use this value over here. Okay, average speed equals to total distance over total time. Bad color I know, okay? 125 over 20. This should give you, oh my god, what is this? 6.25 meter per second. Like that. Okay? If it's too bright for you, then you go home and copy, okay? Go home. Okay? Any question?
Wait, so if there was like a negative region?
Right. Then what happened is you have to calculate this negative region. Okay? Negative region, right? And whatever negative value that you see on your y-axis, because it will naturally be negative 5, negative 10, remember? You have to convert to positive. Because no matter what, this part over here is distance covered, right? No, it's just in the opposite direction only, but the car still move in that space, right? It still move, So this one over here, you have to convert to positive value. That means even though this is like a half times, maybe this is 30, example, so half times 10 times negative 10. This negative 10 here, you must convert to a positive 10. Then this will become your distance. Don't worry, okay? Negative region, I don't think is very popular in your... Let me read, Yeah, you don't have to know. Why? Because it says that it's in one direction. You see your... This one, this first page over here, all of you have it, right? It's very important. Why? Because this one explains to you how your O-level is set. You see point F and point G. What does it say? Deduce from the shape of a distance time, okay, let's talk about G. Deduce from the shape of a speed time graph when the body travel in one direction. So that is to say that you won't even encounter this negative region. You see that? You won't. Okay, so most of the time, what does this translate to? It translates to displacement and distance in a graph like this is always the same. Because you only You only do one direction, you don't do like the two direction one. Okay? Can? Got it? Yep, good. Okay, so don't have to worry so much. Okay, this one. Ready? Can we continue? Are you guys okay? Not dying yet, I hope. Distance time graph, you see distance time graph, you should be very, 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 very happy. Okay, because it's very easy. So same thing first, your thinking process, your y is actually your distance, your x is your time, then your gradient would be your speed. Okay? This is to train your brain to think that way. What is the instantaneous speed? What's the meaning of instantaneous? Huh? At that point of time. Instant, at the instant, I vomited. I didn't vomit throughout, right? I didn't, it's only at that particular point that I start vomiting. So that means to say that over here, I am only interested for you to find out my speed at 5 and 25. So where's my 5? My 5 is here. Ayo, so big. It's here. This is your 5 seconds. And your 25 is here. So I bring it in here. Okay? So I'm only interested to find at 5 and 25 seconds. So what should I do? I have to use at that point of time the distance. To find speed, you must have distance there by time, right? So the distance at 5 seconds would be 5. This gives you what? 0.0 meter per second. At 25 seconds, what happens? Speed equals to distance over time. This gives you, what's my distance? Boop, 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 is here. So this looks like what? Huh? By the way, wait, by the way, do you know how to calculate gradient? That's why I think you guys a bit mistaken me already. You see, how I calculate this. Do you know why I use 5 and 5 over here? Why? What is my gradient? Wait, wait. My gradient is here, right? This is my gradient. Right? Because over here, this particular spot is found on this particular line. And it so happens that this whole line is a constant line. Agree with me? This whole line is a constant line, right? So I could actually use... You need a triangle to find a gradient, remember? So you need like x1, x2, y1, y2, that kind of thing. Why am I doing this? That's gradient, right, girls? X and y. Right? You need your x and your y. Right, remember? That's how you find gradient, right? You need 2 points. Then you draw that triangle thingy to find gradient, right? So over here, why I use 5 and 5 is because over here I take into consideration the point is 0. So that means at this point over here is what? At this point over here, this point here is a 0, 0, right? Coordinate wise. So at this point over here is a 5, 5. Right now, y1 minus y2, x1 over x2. That's the reason why I said it's 5 over 5. Right? Hey, gradient. Hey, okay not? Hey, hello. Are you guys okay? How to find gradient? Right? Because this whole line here, no matter how, okay, this is again, just in case, I'm not saying that you guys are stupid, okay? I'm just making sure that we are on the same page, okay? This is a perfect straight line, am I right to say? So that means at any point over here, if I were to find the gradient, any point over here, the gradient is always the same, right? Okay, so even if I find from here to here, it's also what? It's also 1, right? Right? Okay? But over here, you realize the gradient change. This is the perfect straight line we are talking about, right? But the thing is, I cannot say that, this is 2.5, sorry, 20, what is it? 22.5, then this is 25, then therefore I use 0 to 2.5, that kind of thing. Cannot. Why? Because I cannot take from 0. Because this gradient here wasn't consistent. You realize that? It changes at 20th second. Right? So this thing over here must look in isolation. So that means over here, I can only use this gradient over here to find what is the gradient at 25. Because if let's say, if my gradient at 25, it's, example, 5. Example, my gradient at 25, I go and calculate it, is 5. That means at any point of time over here, the gradient will also be 5. Right? Because it's a perfect constant line, right or not? Yes, right? So what I need to do is this, okay? I need to find my gradient by using 2 points. If you do not know, because we don't start from 0 anymore, you see, so it's not so easy. So over here, the coordinates is what? 20, 20, right? Coordinates, okay? And this point over here is what? 40, 30. Right or not? XY, XY. Right? So to find the gradient for this fellow over here is what? Y1 minus Y2 over X1 minus X2, right? So if I let this be X1, Y1, I let this be X2, Y2. Ayo. Okay, Y2. What happens? So I will use 20 minus 30, 20 minus 40. So it's minus 10 over minus 20 becomes a positive half. Make sense or not? Then because over here gradient is speed, so therefore this will become meter per second. So that's how I do it. See here. Okay, that's the reason why they say physics and math is very related because of this. If you don't understand, go back home and replay the YouTube video again, okay? Then you will be clearer, I hope. Because this is just pure EMAF. Just pure EMAF, okay? Gradient. Next question. They said that to calculate the average speed, same thing. I need total distance, total time, but it's from 10 to 40. So my total time over here would be a bit different because the total time would be 30 already. Seconds, because I'm taking from 10 to 40. Okay? What's my total distance covered? So at 10, what happens? At 10, it actually covers 10. Right? At 10 seconds, it covers 10. Can you see it? Then at 40 seconds, it covers 30. So what's my total distance covered? Is here. This is my total distance. This is my total time. It's 20, right? Right, 20, right? So total distance would be 20. This is meters. So average speed will be, 20 over 30. What do I have? 20 over 30. Oh, 0.667 meter per second, 3SF. You can put it 2SF also can, okay? Any question?
Wait,
because they only wanted the time from 10 to 40. So that's my total time. I must match my total distance with the time. Yeah. Any other question? If not, let's continue. Okay. What is this? Try to come up with a numerical example for the various types of deceleration. Example, variation of velocity for various types of deceleration. Time 1, 25, constant, increasing. What is this? Can we skip? Let me ask Mr. Quack what is going on this. Okay, any more? No, no more. Okay, let me add more stuff behind. Okay, this is a new chapter, so I will need your MCQ to be done by tomorrow so that we can go through a bit of things for your WA1. Okay, so now there's nothing much I can do but to start a new chapter. Okay, I'm actually a little bit behind time already, so I need to be a little bit faster. But also, I do not want to not revise your WA1 chapter with you. So I really need you to do your work, then I can revise, okay? So whenever you want to start a new chapter, okay, how do I get all this information? Do you know that you have to go to SEAB? Okay, let me teach you what to do, okay? You must, in Chinese, we always say that 知己知彼,百战百胜, meaning you must know your enemy, then you will be able to tackle all their weak point, then you can score and win the war, okay? So how do we, SEAB, how do I actually know the enemy that I'm facing for my O-level, okay? I'm going to show you a quick one. You see this one? This examination board is the one that actually tell you exactly what is tested, what is not tested. Okay. Then we have science physics. Let me find last. Okay, here. Yours is, okay, it doesn't matter, okay? It doesn't matter whether it's 5086 or 5087 because the physics is the same. It's just that the other subject is a bit funny. So for you, it's 5086 because you are chemistry. Okay, so over here it displays two different subjects requirement. So the first part over here, if you scroll, okay, it will tell you exactly what is the aim, why you must use it for O levels, things like this, and what is the type of question that we normally test you on. Okay, then after that, okay, see there's knowledge question, there's more like a technological based things where we talk about application question tested. So over here, wait, let me show you something. This is the way the paper is being set with. So MCQ, we sit together. That means you must study two subjects. Then you sit for one MCQ. 40 marks, 40 questions. 40 marks, 40 questions, you're right. Okay, but the thing is, the weightage is only 20%. Okay, then for physics paper, we call it paper number 2. For your chem paper, is paper number 3. These two are structured questions. Okay, structured. That means it could be section B, where it's short answer, or it could be the long answer one. Okay, because it is structured free response one. Then you need to sit for a practical examination, 15%. Okay, so this one will add up to 100% weightage. So over here, more to come. Wait, let me scroll up a bit. Then this is physics will display first. So you see your chapter number 1. Don't fall asleep, okay? I'm teaching you what to study. So over here, this is chapter number 1. How will we test you? We will actually test you on your understanding of physical quantity. Okay, whether do you know that it must have a number and a value? Because they say show an understanding. So how do you show the understanding? So most probably I'll give you an MCQ, ask you to display it in a physical quantity manner. Okay? Or which the following is not a physical quantity. This is called show understanding. You choose A, B, C, D. Then after that, you must know all the basic SI units we will test. Where will we test? Most likely we will test it in a question. What is the SI unit for speed? Okay, maybe I talk about speed time graph. Okay? Then you need to know your prefix. Maybe I give you an answer in km, but I also want you to convert to meters just to have an SI unit. You see? So this is how the teacher will set it. Then over here, this one is by memory. You literally have to memorize the size of the atom, size of the earth, size of whatever. Okay? Because you see, Okay, so this is how chapter 1 will be tested. Chapter 2, kinematics over here, which is what we just finished. Okay, you see? State the meaning. What does it mean? It means that you have to memorize the definition. State what does it mean by speed and velocity. So you must go and memorize what is speed's definition, what is velocity definition. That's called definition. Then calculate. That means you know that in your MCQ or structured question, definitely got average speed question one. Because you're supposed to calculate average speed. See that? Next, in your speed time graph, surely one part of the graph is going to show you uniform acceleration, and you're supposed to calculate using A equals to V minus U over T. See that? Okay, and finally, interpret given example. Interpret means by looking at it, I should know this is a non-uniform acceleration. That means I see curves. When I see curve, it means non-uniform. So that's what interpreting. Whether is it increasing acceleration or decreasing acceleration, things like this. Next, you are supposed to know how to interpret your speed time graph and distance time graph, which is what we did just now. Okay? In one direction, in one direction, in one direction. So you must know how to see whether something is at rest, how to know whether something is uniform speed, uniform acceleration, non-uniform acceleration, non-uniform speed. Okay? Finally, calculate the area under the speed time graph to know that that is the distance. And we will never ask you to calculate the area under the graph if the graph is curved. Why? Because they say it will have either uniform speed or uniform acceleration. To be uniform acceleration means to say that it must be a diagonal line like this. Uniform speed is straight line, which is what we did just now. The trapezium, remember? The trapezium, where is it? Let me show you. You see, speed time graph. BC is uniform speed. Because there's only one speed reading now, which is 10, uniform speed. AB is your uniform acceleration. You see, there's one value for my acceleration. This is uniform deceleration, they can also test. So you see, they follow exactly what SEAB requires you to know. And finally, you must always state that, there is no calculation needed. State that the acceleration of any free fall object is always 10 meters per second squared. That is your gravity. So if you don't know what to study, this is the one to study. That means after reading everything over here, if I actually knows every single answer, how to do and whatsoever, that means I'm done revising for WA1. That's what it means. Okay? So it goes to same thing as other chapters. Behind got chemistry, okay? So same thing over, you see? Where is it? Okay, see, covalent bonding, whatever, kinematics, kinetic particles theory, blah blah blah, not kinematics, sorry. Okay, it's all there. Right? Just go and download it and you can study about it. Okay, so we are going to do quickly force and pressure. So what is force, what is pressure? Anyone? This one is your Sec 2 work, no, by the way. Okay, just a quick one. Finish this, then we can end already, okay? So what is a contact force? Contact force means the object must touch. So for example, now I whack her. Is this a contact force? Yes, because it comes into contact with her. Right? So if suddenly this woman, she feels painful, like no one beat her, no one, she feels, that means it's non-contact force or something that out there is pinching her or beating her. Okay, and that's non-contact force, okay? So over here, some example of a contact force, it means that it is a normal contact force. This is something that a lot of students will get it wrong. Okay? How do we draw a normal contact force? It must always be perpendicular to the surface that is touching. So if I have a block over here, my normal contact force will have to be like that. I don't have to draw from the center. Do you know, in fact, I could actually draw here as well? Like that. I don't have to label the right angle lah. I can draw like this. It's still a normal contact force. I draw here. It's also a normal contact force. I draw here. Also a normal contact force. I draw here. Also a normal contact force. That means as long as my object is touching this particular base and I drew an arrow that is perpendicular to that surface, is considered normal contact force. Got it? Shh. Okay? They love to ask RAM. You think they will give you this kind of question? No. Okay? As a teacher, we will not give simple one. We will give something like this and ask you, draw the normal contact force. Listen. So first of all, I must identify the base. The base is here. This is the base. Right? How do I make my object force perpendicular to the surface that's touching? I have to draw like this. Then it will be perpendicular, ma. See, this will be perpendicular. Must I draw it like this? No need. I can also draw it here. Wait, I could actually draw it here. I could also draw it here. I could also draw my arrow here, anywhere. Just make sure that it's perpendicular can already. You understand me? Must draw within the surface because it's a contact. You cannot draw here and tell me that, hey, this is normal contact force. Cannot. What contact are we talking about? There's no object over there. Clear? Can So it must be perpendicular to the surface towards the object. That means it's how the surface acts a force on that object that sits on that surface. So now you are sitting on the chair. Where is the normal contact force pointing? Towards your butt. Right? Is that surface pointing the arrow back at how the object lands on it? So if I put my hand on the table is pointing an upward force towards my hand. Right? Got it? Okay, next. So this is wrong, because it's not perpendicular. You see that? It's not perpendicular. Okay, there's an angle over there. Okay, so if it's like a pin or a magnet that's stuck onto a fridge, normal contact force is like that lah. Okay, this is normal contact force because it's the surface which is here. Okay, and the object is landing on that surface, so the surface will act a force perpendicular to that object over there. Okay, good. Friction. What is friction? There must be some form of contact and the object sometimes can move, sometimes no need to move. Meaning, for example, if I have, let's say I have eraser. Okay, so this is my RAM. So if I put it like that, if I put it like that, my eraser is not moving. Pretend it's not moving. Okay, it's not moving. You can say, hey, but there's no friction. No object is moving. But you cannot say like that because in order for us not to move, there's a friction that's acting between the surface of the eraser and my phone. It's like how you stand on a slope. Some of you cannot stand on a slope because you will fall down. Okay, but some of you can. You just stand and you didn't fall because your shoe has friction against the slope, so you don't fall. Imagine you wore those worn out shoes. You will slide down for sure. Right? So it doesn't mean that the object is not moving, therefore there is no friction. It's not the case. It could move, it could not move. Okay? Understand? So you see, an object resting on the slope could also slide down if the slope is smooth. So if the friction is not there, then of course the object will slide down. But because the object didn't slide down due to the friction. Okay? So prevent the object from sliding down. Okay? So friction-wise, how do we draw? This is the final thing before I end. How do we draw friction? Some part of the arrow must be in contact in between the object and the surface that has friction. Then you extend it out like this. Then you tell me this is friction. Can like that be friction? No, this is wrong. Okay, this is wrong. It must be some part of it must touch the object and surface. It must touch. Then you extend up from there. Okay? See, some part of it must touch, then extend up from there. See, some of it must touch, then extend up from there. Okay, so this is the one that I'm talking about lah, about my eraser didn't move downwards. It's because of the friction. Okay, so it could be like that as well. Okay, so I beg your pardon. This is the one that is on my eraser. I beg your pardon, I said wrongly because it's at rest. So this is my eraser acting on my phone. It didn't slide down because friction is acting in the opposite direction. So by right, it should slide downwards. Okay, it should slide downwards like this. But because of friction, it actually holds there. Okay, it actually holds it there. It didn't slide down. Because by default, you should go down the slide, right? But this one is a bit different. Okay, the motion, that means the object is moving. This is moving. And moving where? Moving upwards. It's like you climbing up a slope. Friction is acting downwards, going against it. That's why you feel very difficult. Wow, I have to climb an incline. It's very difficult for me. Okay? Because friction is acting in the opposite direction. Okay, no. I'm done. Okay? We will talk a little bit more tomorrow. Tomorrow, please, I need to go through the MCQ correction for your kinematics. So please do it.